guys, Miss Kulkarni here. In this video, we will talk about limiting reactant and we will do a lab activity using PhET simulation and we'll talk about that in a minute. But before that, what is a limiting reactant? It's simple. It is the reactant that limits the reaction progress. What it means is, during the reaction, a limiting reactant is completely used up. So at the end of the reaction, how much is remaining? Zip zap, zero. There is no reactant remaining. Then there is excess reactant. Obviously it says everything with excess. These are the reactants which are present in excess amounts. And they will always remain in some quantity. So the excess amount is something we have to find out how much is left after the reaction. Now, limiting reactant can be very well explained with cooking. Cooking, whatever you're doing, will require always a certain proportion, right? And those ingredients we are going to mix together. It depends upon the recipe which you're following. Before you start your cooking or baking, what you need to do? You need to make sure your pantry or refrigerator and check on, do we have the ingredients available? Okay, if you have those available, how much is the quantity which we need for our particular recipe? So are you ready to bake some cookies with me? Well, you can check a new video which will be coming up soon at home lab activity for you. And right now we are going to work on virtual cooking. So are you ready to cook virtually with me? So let's get started with virtual cooking using PhET simulation. So you can do one of these two things. You can either select this link, which is a direct PhET link, and then select limiting reactant sim from that, or you can also use directly this link which will take you to the PhET simulation page right over here. So this is what the page will look like, and then you can either download, you can embed, or you can just click on this, and then when you click on this, what you get is a new window which will look something like this. So this is a great simulation. It gives you an option to make some sandwiches. Are you hungry? Or you can even use some molecules, have some reactions, and also if you're interested more, you can play some games. So let's start with our sandwiches. So there you go. We are suppose going to make a simple sandwich, a cheese sandwich. This is what proportion is given to you. 2 slices of bread, 1 slice of cheese, and that's a simple sandwich. You can also change and make it meat and cheese. Or you know what? I like to do custom. So I'm going to make the custom sandwich. And then you can decide how many slices of bread you want, how many slices of meat, and about the cheese which you got. So for my sandwich, I will need 2 slices of bread, 3 slices of meat, and I like chicken by the way, and then 2 slices of cheese. Let's see now how much ingredients we have in our virtual pantry. So if I have 5 slices of bread, 5 slices of cheese, and we got 2 slices of cheese. How many sandwiches I can make? I can make 1 sandwich with whatever the custom order I have over here. Then out of 5, remember, we'll be using how many breads? Only 2 bread slices. So I will have 3 slices remaining. That means that becomes an excess reagent. How about the meat slices? I got 5 here and I need 3 for each of that. So how many are remaining? 2. So 2 are remaining. Again, that means I got this also in excess. Look at the cheese slices. How many are remaining? It's 0, none. That tells me that cheese slices is going to be my limiting reactant. So this is one of the example. Now you can switch the number of bread slices, you can change something with the meat, you can also change the cheese slices and come up with different variety of combinations and find out the limiting reactant for each of the sandwich. Just to make it easy, let's take one more example. Now I decided that I will be good with only one slice of cheese, but I still need to keep 3 slices of meat and I want 2 slices of the bread. So if I got 5, 3 and 2 as the ingredients ratio, then how many sandwiches I can make? I can make one sandwich, that's my product. And then I will have 3 bread slices remaining, one of the cheese slice will be remaining, and I end up having my leftover will be 0 for the meat slice. So there you go. You can always have different combinations and figure out which will be limiting reactant to make some sandwich. So are you guys ready to make some sandwiches now? So this is what you'll be expected to do. Be creative and come up with your own custom sandwich. You can even add more ingredients. You don't have to limit to what you saw in that PhET Sim. List the ingredients. Maybe if you want to add tomato, mushrooms, you can add those too. And whatever you want, find out the proportion which you would like. Check your kitchen pantry, or if you don't want to look in your real kitchen pantry, you can also come up with your virtual pantry and then think about what quantity will be available for you to make your sandwiches. Then you're going to sit together and find out with the proportion how many of sandwiches or the products you can make, and then which one gets over first. So that will be your limiting reactant. And at that point, you can easily find the excess reactant after you're done with making sandwiches. Now you know chemistry is similar to cooking. So let's go to our real chemistry and let's do some reactions. If I select the molecules, I come up with this screen where I have 2 moles of water combining with 1 mole of oxygen, giving me how many moles? 2 moles of water. With the 4 moles of hydrogen and 3 moles of oxygen, I can make 4 moles of water. That's my product. But did you see? At the end, I will not have any hydrogen remaining. So what is that? That means that will be a limiting reactant. And how much of the oxygen will be remaining? There is 1 mole remaining. So that will be the excess reagent remaining. So you can do same thing with ammonia or methane and you can probably get the same answers. Let's try one more thing. So there you go. That's the balance reaction for combustion of methane, and I'm sure you all can do that reaction balancing pretty easily. So if I have, let's see, 5 moles of methane, and let's see if I get 2 moles of oxygen. What do I get? My limiting reactant is oxygen because that's all gone, and this will be the excess one which I got there. So see how simple and easy it is to find out which is the limiting reactant. So let's go back to what we are going to work on our lab activity. We are going to use the same concept and we're going to go back with the mole ratio. So you can come up with any reaction which you have studied or whatever you think about, either synthesis, decomposition, or whichever you think is most appealing to you. Get the reaction, write a balanced equation. After that, make sure you get the mole ratio for your reactants, and then be creative when you think about the mole quantity which you have. You can make those up with whatever quantity you have or you dream about. Then you do some simple calculations or use the mole ratio and find out the limiting reactant. Same way, you can also find out which is the excess reactant and how much of that will be remaining. This is going one step higher and I am sure you all can do that. So now we are going to work on mass of the reactants instead of just using the moles. So what you can do is expand that idea with cooking and baking and come up with, instead of having the amount in moles, to grams. So if you have a balance available, you can take the mass of the reactants which you have. Like if you're taking flour, sugar, you can take the mass of those reactants. If you don't have, don't worry. You can also make some hypothetical values for that. And then using stoichiometry, you can identify which is your limiting reactant. In case if you want a little help, you can also use this conversion table. How can you go to the heart, which is mole, from either particles, volume, or mass? Right now, you'll be going only from mass to moles. If you need little help or guidance, make sure to watch other limiting reactant videos too. So again guys, be creative. Come up with your own idea, either baking or cooking. If you're following a recipe or making a new recipe, either one is fine. And come up with the amount which you have, or you can actually take the measurement with cups or grams, and tell me how to find limiting reactant, and also identify your excess reactant and how much will be remaining for next time baking or cooking. If you are interested in having some more fun, there is a game. Yes, there is a game for limiting reactant, and you can play it and find out more about limiting reactant. So I hope you guys enjoyed the video, and I will see you again in next video. Until then, bye bye.